Today, let's talk about an exciting new space startup company, Varda Space. Their business plan is space manufacturing. Yes, now you can manufacture materials, pharmaceuticals, and chemicals right there in the vastness of space. Very few companies are working on space manufacturing. Now, you might be scratching your head wondering, why on earth would I want to make stuff in space when I can do it right here on this little blue planet? Well, the reason is that without gravity, you can make purer forms of chemicals or pharmaceuticals that have superior characteristics and performance. Big pharmaceutical companies such as Eli Lilly and Merck have already collaborated with the International Space Station to work on better drug development. The amount of time a NASA astronaut can spend on these experiments is limited though. Varda can provide a dedicated service for the processing and manufacturing of chemicals and pharmaceuticals in space. It's not just drugs though. Important chemicals used in electronics, such as silicon, benefit from being manufactured in space. You may not know this, but small pharmaceutical molecules can be worth millions of dollars per kilo. Any molecule that can be manufactured that is worth more than the launch cost can be profitable. Typical launch costs are in the $1,000 to $10,000 per kilo and likely to fall in the near future due to larger launch vehicles coming onto the market, such as SpaceX's Starship. Just look at this chart of small molecules and their price per kilo. It's staggering to see how much these tiny molecules can be worth. Varda Space Industries aims to produce valuable molecules in space, starting with simpler, smaller ones, and gradually advancing to more complex and larger molecules like Keytruda. These larger molecules can be worth billions of dollars due to their life-saving qualities and the very small doses needed to be effective. Varda is the only company out there making space drugs. They can rake in the cash with upfront payments, milestone payments, and royalties. Depending on how these drugs do in the market, Varda could be looking at tens of millions of dollars per drug. Who knows, maybe one day they'll make their own space drugs, cutting out the middleman and taking all the profit. Let's talk about fiber cables. In space, the lack of gravity allows for the production of ultra-pure Z-band fiber optic cables, which can transmit light over longer distances and with 10 times the data capacity of their Earth-made counterparts. These cables are highly valuable due to their ability to transmit a broader spectrum of light than silicon, including ultraviolet and deep infrared. Currently, transoceanic communications rely on undersea silica fiber optic cables that require repeaters costing $1 million every 30 to 60 miles. Z-plan cables could reduce the number of required repeaters by a factor of 15, significantly lowering the cost of undersea cables. Manufacturing a Z-plan in space would not only be extremely profitable, but also improve global internet connectivity. Better solar panels. In the 1990s, Alex Ignatieff from the University of Houston developed gallium arsenide semiconductors in space that were 10,000 times better than Earth-made ones. The space environment allows for precise, distortion-free growth of these semiconductors, potentially boosting their solar efficiency to 60%. These effects are locked into the material, typically through material crystallization before being brought back to Earth. Varda is building infrastructure to complete two tasks. One, in-orbit production equipment to manufacture materials for multiple industries, and two, a robust, reliable, and economic re-entry capsule. First, let's look at the manufacturing equipment Varda is developing. Due to the constraints of manufacturing in space, Varda is developing its own equipment. The equipment needs to be ultra-reliable since it cannot be serviced or repaired while on orbit. Secondly, return capsule. Varda's capsules are like the cool, space-age cousins of the Crew Dragon. They don't need all the fancy life support systems, but they do need to handle some serious G-forces and wild space moves without breaking a sweat. After all, the cargo they're carrying is super valuable, so it has to be able to handle the heat, the shakes, and the stresses of space travel. Re-entry. Varda's capsule is designed to re-enter materials processed in low Earth orbit before landing under parachute on Earth. Once landed, materials and payloads can be safely retrieved for use by the people that need them the most. Post-processing. The journey doesn't end when the capsule lands. Varda has its own labs to give the materials a good once-over. They check for purity and make sure everything went according to plan during manufacturing. They also team up with partners and customers to double-check their work. It's like a space-age quad control system, but with more lab coats and fewer astronauts. Varda has assembled a talented team of professionals to help make space manufacturing a reality. Co-founder Will Brewer is a 6-year SpaceX veteran and one of the select few who have built and flown commercial space vehicles. Brewer previously worked at SpaceX as the lead hardware engineer for the Crew Dragon and worked in mission control for 8 ISS missions. Co-founder Delian Asfavhav, I probably butchered that name, sorry, is a repeat founder and one of the smartest investors in space, with experience at 2 leading VC firms, Kozler Ventures and Founders Fund. Key milestones. Let's go over the key milestones Varda has achieved so far. In March 2023, Varda was awarded a $60 million contract with the Air Force. The Air Force wants to use the Varda re-entry vehicle as a hypersonic test bed. The Air Force is currently working on various missiles that fly at hypersonic speeds. Understanding the hypersonic environment is an urgent need for the Air Force. Varda's re-entry vehicle can assist in accurately modelling the dynamic forces and stresses encountered during atmospheric re-entry. The contract covers 2 flights, 1 rideshare flight and 1 dedicated flight, and additional work to create an enduring capability. Varda anticipates it could be doing 4 to 6 missions per year on hypersonics alone soon. Varda thinks this contract could be a springboard onto more and larger Department of Defense contracts. July 2023, NASA awards Varda Space a tipping point contract. The award was for, and I'm quoting here, 1.9 million conformal phenolic impregnated carbon ablator tech transfer and commercial production. That's a mouthful. Let's just call it CPICA. Developed by NASA, CPICA is an improvement over the standard phenolic impregnated carbon ablator. The conformal part just means it can be shaped to fit the spacecraft's contours, providing a snug and custom fit. This material will dissipate the heat from re-entry and keep the inside of the capsule at a comfortable temperature. June 2023, first test flight. Varda's focus for this flight is to achieve a successful re-entry of the vehicle, deployment of parachutes, and a safe landing in the Utah desert. Varda launched its spacecraft to orbit on the 12th of June 2023. The first mission focused on crystallizing ritonavir. This is a medication used to treat HIV. This test was to explore how microgravity influences crystal structures. 2 weeks after launch, the mini-lab got to work on its microgravity experiments. After the on-orbit lab completes its work, it's time for the capsule to come back to Earth. When the capsule re-enters the Earth's atmosphere, it will reach speeds of over Mach 25. Once it reaches the lower part of the atmosphere, it will stabilize and slow down. Maximum deceleration will be 12 G. At an altitude of 10 kilometers, it will deploy parachutes and land in the Utah desert at about 5 meters per second. After months of negotiations with the FAA, the Federal Aviation Administration, for re-entry clearance, Varda landed its capsule in Utah on the 22nd of February 2024. Our processes and hardware performed flawlessly throughout in-orbit operations, re-entry and recovery operations, Varda wrote on X. We successfully crystallized the least stable metastable Form 3 in orbit and brought it back to Earth. Varda was able to successfully manufacture and return a pharmaceutical drug in space. A molecular sample analysis released confirmed the company produced crystals of ritonavir. Crucially, Varda demonstrated the ability to keep the sensitive crystals stable during the highly dynamic re-entry through the atmosphere. Varda was able to keep sample vial temperatures below 23 degrees, despite the nasty plasma-filled environment outside the capsule during re-entry. The second mission is scheduled for 2024. Varda Space may decide to land the second capsule in Australia. This is due to delays in receiving approval for landing in the US. Australia has large uninhabited areas to land in, making re-entry licenses easier to obtain. Future plans for Varda. In time, more and more manufacturing can be done in space, with the potential to use materials from asteroids as feedstock. That's a big vision. It can break the scarcity imposed by Earth-bound materials. There's an unlimited amount of raw resources and energy in space. It certainly is an exciting future. Thanks for watching. Please like and subscribe to see more videos like this on other small startup companies in space. We have plans to cover another space manufacturing company soon, as well as launch providers, commercial space stations, space tugs, orbital debris removal and more. See you soon.